if you don't hit a certain carbon budget for your project, you might be fined, or if you're not fined by the government, there'll be a financial penalty by the developer, who's the customer of the contractors. So there's even more of a financial incentive nowadays to not just care about the schedule, which is expensive if you overrun, but also care about the carbon footprint you have.
This series of episodes was recorded live at Digital Construction Week 2025 at the Excel in London. I got the privilege of interviewing some amazing people that are shaping the future of the built environment through the technology that organizations are developing and delivering now and for the future. Although this podcast was worth the entry fee alone, let's admit it, now is the time to register your interest for next year's Digital Construction Week 2026. But if, like me, you can't wait until next year, check out Digital Construction North on the 19th of November. The links to both events, as always, are in the show notes. But just before we go live with this week's episode, here's a brief intro to the topic we cover and today's guest. Concrete forms the literal and figurative foundation of the built environment. Yet, its role is often overlooked in conversations about innovation. As pressure grows across the construction industry to deliver projects more sustainably and with greater resilience, the systems surrounding this material are beginning to shift. Digitalisation is no longer confined to design software or post-completion analysis. It's reaching deeper into materials, methods, and real-time processes that shape how buildings and infrastructure come to life. At the same time, clients and contractors are increasingly looking for smarter, more connected ways to plan, monitor, and optimize across the entire project lifecycle. It's time to cure this conundrum with someone who has solid knowledge in this area. Sorry, but then again, not sorry for the concrete gags. Dr. Djelal Osman's work is shaped by his extensive experience in both fundamental physics and applied artificial intelligence. Currently, an algorithms engineer for Converge, he operates at the intersection of technology and sustainability, developing AI and machine learning models to reduce the carbon footprint of the construction sector, focusing particularly on optimizing concrete mix designs and usage to minimize embodied carbon. Prior to this role, Djelal co-founded an augmented reality startup, Ascension, creating novel computer vision algorithms. His academic foundation includes a PhD in physics from the Quantum Sensors Group at the University of Cambridge, where his research focused on the physics of low-temperature imaging detectors used in orbital space telescopes. Welcome to Digital Construction Week.
Thank you so much.
So let's start with who you are and what you're doing here.
Sure. Thank you so much for having me. My name is Djelal Osman. I'm an algorithms engineer at Converge, and I basically work developing machine learning software and analytical tools for construction monitoring and concrete, everything related to the concrete construction process, essentially.
And that's what I'm really looking forward to this episode, because going round Digital Construction Week 2024, I noticed Converge, and I'm sure you had a stand at a small stand in one of the hubs.
Right.
And I tried to catch somebody's attention last year and just didn't get around to it. People were busy and things like that. This year, it's great to have somebody that's got that knowledge of what's going on inside. So I'm really looking forward to this. So let's get into it. So first question. Let's dive right into this, by the way. In what ways is the integration of digital tools streamlining the management of concrete within the built environment?
Yeah, that's a great question. I mean, concrete is a very old industry, and it's mostly been just pen and paper for forever, right? And with the introduction of computers and Excel spreadsheets and so on, there has been some digitization. But the problem with those forms of digitization, like spreadsheets, are the sort of siloed nature of the data that ends up being created, and the sort of mishmash of ideas and terminologies that end up being used. So, for example, we often find, even today, that on a construction site, two different people talking about the same pour will call that pour a completely different thing, right? And they'll write it down with different names, and they'll call the same mix design completely different things. And this ends up being digitized in a way, and it makes the data sort of difficult to use down the line and difficult to reconcile at the end of the project. So one really key use of digitization in concrete has been to make the data creation process more uniform, and everything having the same name, and everything sort of like, it sounds simple, but it's actually like incredibly important for everyone to call the same mix the same name. And even from the batching plant all the way to the site, they'll all have different terms for the same things. And just being able to have a uniform sort of terminology has been a game changer in the industry. And beyond that, like at Converge, we've developed a system called Data Hub, which has helped to reduce this sort of like manual labor and manual effort in data QA recording. So, for example, on a construction site, somebody will have to store all of the delivery tickets, which are on a piece of paper, and they'll have to store all of the QA cube crush results, which are used to assess whether the concrete, is still the appropriate strength and has the same specification. And at the end of the project, they'll have to reconcile those things, go through a whole like reams and reams of papers and paperwork, and put them all together again on an Excel spreadsheet for record keeping purposes. And that can take hundreds of hours of an engineer's time. But what we've developed with Data Hub is a system that integrates directly into the supplier's database and into the lab's database that crushes the cubes, and we'll reconcile all of that on the go, or as the project's even being constructed. Wow. And we also incorporate additional information like carbon tracking information. So we already know the volumes being poured because we integrate directly with the supplier's database, and we use that volume information to state in real time the embodied carbon of an element, or the embodied carbon of the whole project as it goes on. And that's something that nobody would have been able to do before, really. And it would have been a huge headache, and it is a huge headache today for people to try and track carbon as it becomes more and more important for them to do so in projects. And beyond the sort of ordinary data hub sort of use case where you're just trying to merge data together, there's also the use case of using analytics and predictive tools to sort of try and predict what the concrete performance will be down the line, and how to react your program to any changes in weather or changes in other aspects that might affect the concrete curing.
Yeah, I mean, that was so eloquently put. Really, really good explanation. It was interesting to hear you talk, because you started at the very start by saying pen and paper.
Yeah.
And then we moved on to Excel spreadsheets. And now we're at where we are in terms of data and information. And if you look at agriculture and construction, they're the laggards in technology, or they have been in the recent past. And then you look at concrete, it's like, if you were to give me anything, I think concrete would be one of those right down the list of, well, you can't do anything with concrete. Concrete is concrete. There's no technology that can help us here. But as we'll explore, there is, which is cool. So let's talk latest developments in sensor technology for concrete monitoring then, and get into that. How do you continue to improve solutions that you're providing for your clients?
Yeah, that's a really good question. I think it would be helpful to sort of frame concrete monitoring and technology for concrete monitoring in a historical context, because the traditional way of monitoring concrete strength was, a truck comes on site, you take some concrete out of that truck and you batch some cubes or cylinders, depending on which country you're in, and you send them off to a lab and they cure those cubes or cylinders in a water bath at 20 degrees C. And then say 3 days down the line, you'll call up the lab and say, can you crush one of the cubes and tell me what the strength was? And then they'll tell you, and if it's the right strength for striking the formwork, you'll strike the formwork. If not, you'll wait a little longer and tell them to crush another cube. But obviously, that isn't really aligned with how concrete really cures, like in situ. Okay. When you pour concrete on a construction site, it's not curing at 20 degrees C. And the hydration process of cement, which is the chemical reaction going on as it hardens, is incredibly temperature sensitive. Mm-hmm. So when it's colder in a real environment, if it's 10 degrees outside, it cures a lot slower. And if it's warmer, conversely, if it's warmer, like 30 degrees outside or 28, it will cure a lot faster.
Yeah.
So this was the sort of impetus for people to come up with an in situ monitoring technology. And a decade ago, it wasn't really used much, even though the standards existed. But that was when it started to pick up. And Converge, we created sensors that were embedded inside the concrete in order to measure the temperature of the concrete as it's being poured. And then we use what's called the maturity method to then infer what the strength was in situ. And that gave contractors, most of the time, it sped up the project, because 20 degrees C is not really the temperature of the concrete. It gets very hot. When you pour concrete, it can get up to 40, 50 degrees C, especially when it's a thick element and it retains the heat. So usually it just speeds up the project. But what's also great is the safety aspect, because whenever it was really cold outside and the concrete didn't really hit 20 degrees C for very long, your cube crush results at the lab end up being an overestimate of the strength. And so you don't really want to strike the formwork too early, for example, in that case, and something go wrong. So there's like a safety aspect to embedded concrete monitoring, and there's a speeding up the project aspect. But that's like the historical framework and where we're at sort of up till today. But what we're developing at Converge now is, with all of this wealth of data that we've got from all of these embedded devices, we can develop systems that can predict how long concrete would take in the future at different times in the year, based on what the forecasted weather will be, weather conditions, and what that allows contractors to do, which they've never really been able to do before, is have like a data-backed method for understanding how their program will be affected all year round for using some particular mix design. And that's can be used several different ways. One way is you could say, I want to make sure I don't go that the program doesn't take too long. I don't suddenly in the winter start having to strike at 3 days instead of 2 days. But it also could be some speed ups, some efficiency wins, and you could end up striking 1 day instead of 2 days. But more so now, what we're able to do, especially with the sort of mix AI type systems we're developing at Converge, is to help contractors see that gain in the summer from the increase in temperature outside as surplus performance that they can sort of trade for a lower carbon mix design that would normally cure slower. But using our systems, we can tell them, okay, you wanted to hit a 2-day strike time. Now your mix is hitting a 1-day strike time. Why don't you use that day difference to use a lower carbon mix design and hit a 2-day strike time again, if that makes sense. So they want to keep a fixed schedule and to trade off all surplus performance for carbon savings. And that's what we've been developing at Converge, and it's been really it's been received quite well thus far in the industry.
And other than like rendering and things like that, I think the pouring of the concrete is the one element that is hugely determined by the weather and hugely determined by the curing time as well. And it I was kind of laughing a little bit there, that it always fascinates me that you can take any industry, any component, any product, and it's always a lot more complex than you think. And it's like just hearing you talk about concrete, which if you've ever been in the industry or done anything at home, you just pour it and then you wait a few days and it's cured and then you crack on. But when you're talking about mega projects and large projects and the timescales and how a delay can hugely impact the tight margins that exist, like that's almost a game changer where you start to get information about the weather and the mix and what will fit your schedule. That's unreal.
Yeah, and now as we move into the near future, there might even be carbon related costs. So if you don't hit a certain carbon budget for your project, you might be fined, or if you're not fined by the government, you might be there'll be a financial penalty by the developer, who's the customer of the contractors. So there's even more of a financial incentive nowadays to not just care about the schedule, which is expensive if you overrun, but also care about the carbon footprint you have.
Yeah.
Yeah.
And it kind of makes sense that you'd use sensors in concrete, because we have sensors everywhere that you don't realize, you don't notice, you don't recognize that are embedded in things.
Right.
Yeah, I suppose because of the hardness and the robustness of concrete, that you don't really think that there'd be a use for a sensor in it.
Yeah, that makes total sense. I mean, the fact that the concrete is the curing of concrete is temperature dependent is the main reason why you'd want to put a temperature sensor inside concrete. But another problem, obviously, as you're saying, concrete is extremely hard and thick, and when you put a sensor inside the concrete, the problem you have is, how do you get the data out of that sensor? So the first iterations of concrete sensors were you'd put a wire inside, which would have a temperature sensor on the end, but that wire would always be sticking out, and you'd have like a device outside that would record. But then we evolved to creating wireless embedded systems, where you place a sensor inside and you use Bluetooth or low energy Bluetooth to extract the data. Then with that comes like a range problem, because you have to always be within, say, 15 meters from the pour. And you can move your recording device around, but it always has to be relatively close. And now with the next generation of sensors, we've gone towards LoRa, which is another sort of paradigm of Bluetooth transmission, but we can get up to like a kilometer away, or 500 meters or a kilometer away from the pour in order to measure it. So it sort of makes the whole system more wireless, which is important on a construction site. You don't want wires everywhere. You don't want to have to plug things in all the time, which is a huge nightmare. Especially when you're like out in the desert, for example, which is some customers we have are deep inside a tunnel, like 500 meters within a tunnel, or like 500 meters into the desert. And it becomes tricky then to get a recording of the data. But yeah, the next generation of long range wireless recording has sort of overcome that issue.
Yeah, you need to come around to my house and sort my Wi-Fi out, because literally, I mean, I'm 10 meters away in a separate room, and there's no signal. We need to do something about that first. Anyway, I digress. Moving forward, how is AI going to impact, I suppose, Converge, what you do, but also the concrete pouring and mixing in the industry in general?
Yeah, that's a really good question. So at Converge, we have a couple different sort of AI-based products that are related to concrete. The one that I mainly work on is related to predicting for a given mix design how it will cure throughout the whole year based on the weather at that location, and also the element shape. It matters as well. If you have a thick element, it will retain more heat than a thin element, and that impacts the curing time. So we use at Converge, we use AI systems to help a contractor predict the performance even at the tendering stage of a project. So it helps them understand what sort of the lowest carbon mix designs that they can use that will still hit their target program and will also be within budget. And it makes them competitive against other contractors that don't have a sort of AI tool to help them do that. We also have a logistics AI based tool, which is around precast elements. And you might be already familiar, but when if you go to a precast facility where they cure the elements in advance and they put them out on a, like 2x2 kilometer square like yard, they'll put them out there and they'll tag them, but they'll lose them. I mean, it's kind of crazy, but people often lose elements that they cast and they have to recast them. And so we have systems now that tag with Bluetooth transmitters each of those elements, and then we monitor where they are live. Okay. And we also help the crane sort of come up with the most efficient way of moving the elements around based on the project. So then you're saving carbon and energy and time from crane usage. It's kind of like, have you ever played the game Towers of Hanoi, where you have you've got these 3 stacks of wheels, and you have to stack them, you have to move them around so that they stack from like the largest to the bottom to the smallest to the top. Yeah. So a precast construction site is just like that, where they stack all the elements on top of one another, but they want to get the 1/3 one down. And then you have to decide where are you going to put the other 2 based on what's going to happen next. And this is a system that we've also developed to help precast.
Okay, fantastic.
Like be more efficient.
So it's not just the pouring, it's not just the element that's internal. It's a wider scope that you're really focusing on.
Yeah, our goal is to sort of target the whole concrete like construction pipeline. Yeah.
Okay.
And make it more efficient.
Yeah, so let's stick with that and making things more efficient and more sustainable, because as we know, concrete is a huge carbon emitter of and from an environmental perspective, it's always that focus on concrete. But with the data that you're collecting, and that's ongoing, so it's just going to get bigger and improve what you're doing. But what benefits does the data that you collate bring to project efficiency and sustainability?
Yeah, so I think it's really about, with Mix AI, for example, it's really about being able to predict how the concrete will cure long in advance before the project begins, because that allows you to maximize your carbon savings by choosing the lowest carbon mix that will meet your program.
Yeah.
And that is the key, I think, for saving carbon with concrete. And as time goes on, there are a lot of novel low carbon concrete mixes that are coming into the market, or at least, these novel concrete mix designs will take 20, 30 years before they really hit the market, but we can see them on the horizon, and a system like ours is able to predict how those mixes will perform based on a few different sort of measurements taken in advance. So it will allow people to have more confidence in these low carbon mix designs, because a lot of time we see contractors just scared of using a low carbon mix, like with a high amount of cement replacement, because they're just worried it will take too long. And showing them some real data, real evidence, just gains confidence for them to be able to use it, and then it just changes the mindset of the customer to use low carbon mix designs.
So do you think, with the data and the information that you're collecting and the future going forward, do you think it's just going to get more efficient, better predictability, and is there any other areas where that data is going to help facilitate, well, efficiency and predictability, I suppose?
Yeah, I think it will become really important to have all of this data and all these like pattern recognition systems, like machine learning tools that predict performance. It'll be really important when you're trying to optimize whole new mix designs and change the recipe and try and figure out, well, if I were to adjust this mix by this percentage in this element or this like constituent, then how will it impact the workability, or how will it impact the mix performance in situ? Because these things the in situ performance is related to so many different factors, and it's very difficult to be able to, as a human, understand how all those factors like come together to what actually happens on the ground. Like the shape of the element, the recipe, the environmental aspects like humidity and temperature, they all play a role, and being able to understand how all of those things play a role in the performance is not really like a sort of manual human intuition type like type problem.
Finger in the concrete.
There's just too many variables.
Yeah.
So I think another thing that might come out of or we hope will come out of all of these all the data that we're gathering is just insights that nobody would have been able to figure out otherwise, like connections that causal links that other people wouldn't have been able to figure out unless they did use AI systems.
Cool. Exciting time, really.
Yeah.
And going to the future, it's really exciting to see the journey that you're going on and what comes. So final question then, talking about the future. Digital Construction Week, 10th year. What should we expect to see in 10 years' time in digital construction?
Yeah, it's a good question. I mean, there's been digital construction or digitization in construction has technically been around for a long time, right?
Yeah.
Like Digital Construction Week has been here for 10 years. If you look around, there's so many different digital tools here for helping in the construction pipeline. But the construction industry remains very under-digitized still today. And like I said earlier, people are still sort of writing things down on pen and paper. Even today, people are still making spreadsheets with completely unmatched words for the same thing.
Yeah.
You know? So I think like what really needs to happen is a kind of societal shift outside of a technological shift. And I think that will happen. It's kind of like how do the actual team on the ground view data itself? Because the more use they get out of the data, as that happens now with more technological development, the more they're going to actually care about the data, and the more they're going to worry about calling something different and getting a weird result in the end because of that. So I think the biggest impact that would happen, that will have the biggest change in construction, is that people will actually care about the quality of the data they're producing, and that will just magnify the utility of all the tools that exist at the time, and we get this like what we call a conversion. There's something we call like a golden thread, which is the idea that you have exactly the same naming convention throughout the entire construction pipeline of the same thing. So right from the aggregate quarrying all the way to the mix supplier to the construction workers on site, they're all calling the same thing, the same code, the same words, and then you unlock huge benefits out of data analysis from. So I think what we'll see in 10 years' time is more of a holistic end-to-end use of computational insights that would have never been the case unless people actually cared about the data and like tried to make it consistent throughout the whole pipeline.
Fantastic, Djelal. I never thought concrete could be so interesting, but you've made it interesting. So it's been an absolute pleasure having you on today. Thank you so much for joining me.
Thank you so much. Thank you.